Okay, class. This lesson, lesson 8.1, is on the geometric mean. The geometric mean is the positive square root of the product of two numbers. Okay, that says a lot, but we're looking for square roots, which is why I had y'all do that, practicing radicals, and it's the product of two numbers. So let's see, to find the geometric mean, you're gonna do three easy steps. First, you're gonna set up a proportion where the mean is x. Okay, that means, for example, if you want to set up the geometric mean of the numbers 4 and 9, you're going to have 4 over x, okay, and x over 9. These two are going to stay in the same place. Always. Alright, the x's are going to stay bottom here, top there. And you're going to put your other two numbers right here. Okay, and then we're going to cross multiply. So I have 4 over x equals x over 9. I'm going to cross multiply. This x times x is x squared. Okay, and 4 times 9 is 36. Then I'm going to simplify. Okay, I'm going to square root both sides. Okay, when I square root a square number, it leaves me with just that number, so I just have x. X equals the square root of 36, which means the square root of 36 is 6. Okay, so the geometric mean of 4 and 9 is 6. Alright, find the geometric means of these numbers. Okay, we're going to set it up. We're going to set it up 6 over x equals x over 15. That's our first step to set it up. Our second step is to cross multiply. Here we get x squared equals 6 times 15, which is 90. Okay, and our third step is to simplify. I'm going to square root. Alright, this leaves me with x. This leaves me with the square root of 90. Well, remember yesterday we broke down our radicals. This is 2 and 5, this is 3 and 3, and whenever we have two of a pair, we take them, put them outside of the radical, and everything else stays inside. So we have 2 times 5, and this gives us 3 times the square root of 10. Okay, so the square root, or the geometric mean of 6 and 15 is 3 times the square root of 10. And the square root of 2 and the square root of 3, 2 times the square root of 2 over x equals x over 3 times the square root of 2. Okay, pay attention here. This is x squared. That's easy. But this, okay, we're going to do this one at a time. This is going to give us 2 times 3 times the square root of 2 times the square root of 2, which is the same thing as the square root of 2 squared. And anytime you have a square root squared or a square root times itself, you're going to get rid of the radical sign. So this is just simply 2, and this is 2 times 3. Okay, so we have 2 times 2 times 3, which is 4 times 3, which is 12. Okay, so x squared is going to equal 12. Well, we need to find what x is, so we square root it. This is 4 times 3, and if you notice, this is the prime factorization of 12. So we know we have, let me go ahead and write it for you. We know we have 2 2's. Alright, so the 2's are going to come outside the radical, and the poor little lonely 3, he's staying inside. So the geometric mean of those two numbers is 2 times the square root of 3. Okay, now the next part of this lesson is a little bit trickier. Altitudes on a right triangle. Okay, remember the altitude goes from the vertex of the right angle down to the hypotenuse. If an altitude is drawn, okay, this is altitude, notice it here, okay, is drawn from the right angle to the hypotenuse. That's the longest side down at the bottom. The two triangles are similar. So we know that triangle ABC is similar to triangle BCD and similar to triangle ADB. And the altitude is the geometric mean of the two segments of the hypotenuse. Well, here we go. Geometric mean. How do we tie it into triangles? Well, the altitude is going to be the geometric mean of the two parts of the segment, which means we have this part and this part. So whatever those two parts are, the altitude here is the geometric mean of those two parts. All right, so let's put this into practice. AD is 3 and DC is 14. I want to find BD. I want to find my altitude. So what am I going to do? I'm going to follow my steps. I'm going to have 3 over x equals x over 14. So x squared equals 3 times 14. 3 times 14, which is 42. I'm going to square root it, and the square root of 42, x is about 6.5. Okay, it's one of those numbers. It's going to be 7 times 6, and 6 is 2 times 3, so we're still left with 2 times 3 times 7 inside the little box inside the radical, so it doesn't really work out that well. But if you use your calculator, it's about 6.5. All right, and the measure of a leg, okay, this right here is a leg, is the geometric mean of the hypotenuse and the part of the hypotenuse that's next to the leg. Okay, so this whole thing here is the hypotenuse, and then this is the part of the hypotenuse divided by the altitude. Okay, this is the part that's next to the leg. So CA is the geometric mean of TA and SA. Okay, this whole thing here, the whole hypotenuse, and this small part here. And bonus, let's see if I can highlight. Let's highlight it in blue. This segment here is going to be the geometric mean of the whole hypotenuse and this little part here. Okay, all right, so let's get to figuring this out. If TA, which is the hypotenuse, is 25 and SA is 5, SA is 5, and this whole thing is 25, I want to find CA. I want to find the leg. The leg is my x. All right, so I'm going to put my geometric mean to use. 25 over x is going to equal x over 5. This is x squared equals 125. I'm going to square root it. I'm going to square root it. X equals, let's see if I can break this down a little. I know that this is 5 and 25. I know that this is 5 and 5. I've got a pair of 5s, so I'm going to bring them outside and leave this poor little one here inside all by himself. So the leg here is going to be about 5 times the square root of 5 in length. Okay, I know it's a lot to digest. We're just going to have to keep practicing. Now it's your turn to do this problem. I'll help you set it up. If ds is 5, okay, if this segment here is 5 and this other segment is 10, okay, hence the whole hypotenuse is going to be 15. Okay, I want to find the x. So here's the sections I want. Okay, I want, if I'm looking for this leg, I want this part here, and I want the whole hypotenuse. Okay, set it up. You're going to have something over x equals x over something. All right, put it together, and that is your assignment.